Okay, in this video, I am going to explain milling machine operations. What are the different operations we are going to perform on the milling machine? I want to explain in this video. So, the milling machine operations refer to the various processes and techniques used to shape, cut and finish workpieces using a milling machine. Milling machines are versatile tools that utilize rotating cutting tools to remove material from the workpiece to achieve the desired shape and finish. Here are some common milling machine operations which are used on the milling machines. First one is face milling. I will explain in detail about each and every the milling operation. First we will see the what are the different possible operations can be performed on the milling machine. I want to explain now. Second one is end milling. Third one is the slot milling operation. Fourth one is contour milling operation. Fifth one profile milling operation. Sixth one peripheral milling operation. Seventh one gear cutting and slab milling, plain milling, pocket milling, helical milling, climb milling, hub milling, straddle milling, gang milling and saw milling. These are the different operations we are going to perform on the milling machine. Now let us see the one by one. The face milling. Now you can see that the face milling operation how we are going to perform. Let us see this workpiece, okay, and this is the cutter. So the cutter that axis is perpendicular to the surface of the product. So this operation can produce the flat surfaces. So whenever we want to produce the flat surfaces, then you can choose this face milling, and the cutting tool rotates. This is the cutting tool that rotates perpendicular to the surface being machined. And to create smooth and precise flat surfaces you want to create by using this face milling operation. So removing the large amount of material quickly is possible by using this type of milling operation. So you can prefer wherever required the large amount of the material quickly, then you can operate this face milling. Next, end milling. Now you can see that clearly you can observe this end milling, how that workpiece and how this the tool will be there. Now you can see that this is the face end mill. This face end mill will rotate and moving downward direction inside the workpiece in order to take the depth of cut, that axial depth of cut. So that depth of cut will be in axial direction, and this workpiece, and we are giving the feed to the workpiece in this direction. You can show in this direction of the feed direction. So this is the workpiece. This workpiece will move in this direction, and the total feature depth is also given. Now you can see that how the end mills are having this. These are this. You can observe these two are the end milling cutters, and it is used to cut in both the directions. So mainly this the end milling operations to create flat surfaces, contours, pockets. Such operations can be performed by using this end milling operations. So rotary cutting tool with cutting edges on both its periphery and end face. Now you can see that on this periphery and on this end face also their cutting edges are there. So these are acting to remove the material on the bottom and on the surfaces side also. So both the ways the material can be removed using this hand milling cutter. So end milling can be performed on vertical and horizontal milling machines. You can use the vertical milling machine or horizontal milling machine. You can perform these end milling operations. So it looks like a drill bit, but it is capable of side cutting and plunging operations can be performed, and making it suitable for a wide range of milling operations or milling tasks. So you can observe, see that these two are looks like a drill bit, but it is not a drill bit. Drill bit having only two cutting edges at the bottom, and those two cutting edges are acting and removing the material. But whereas in the end milling cutters, it is having the there is several cutting edges at the bottom and also as well as on the sides. These two are acting cutting edges, and remove the material simultaneously at the bottom and at side surface also they remove the material, but drill bit is not possible. So that is the difference of the drill bit and mill. Though it is looks like the same, but it is a different. Now go for the next operation, that is the slot milling. So now you can see that using this slot milling you can perform the different slots, T slots, V slots or C slots, whatever requirement of the slots you can perform using this slot milling cutter. Now you can see that so this is the T slot. You can perform the T slots with the help of this T slot cutter. This is the slot milling. Okay, you can observe how the cutter is looks like. This is the cutter is looks like, and it will be cutting in this whatever the size of the cutter you can use it according to your size of the slots, whether T slots or V slots or any other required shape of the slots can be performed by using the appropriate cutting tool. For this T slot, you can see this is the cutting tool we are using to perform the T slots. It creates slots or grooves, and cutting the narrow straight channel or slots are used to cut by using these slot milling cutters. So to produce the keyways, T slots, internal and external splines that we can perform using these slot milling operations. The splines on the shafts we are providing the rectangular projections. Okay, so that cutting are we can perform by using these slot milling operations. Next, contour milling. So now you can see that this figure, you can observe this figure. So there is a different contours. You can see that here this is one contour and this is another contour. Here it is like that. There is several contours you can perform by using this contour milling cutter. Okay, it's remove the material from a workpiece along a specific contour or path, and to create complex shapes, profiles or cavities by using these contour milling operations, and to create complex shapes, profiles or cavities. Next, profile milling. Now you can see that profile milling, you can clearly observe this the tool. Okay, now you can see that clearly observe this profile tool. Okay, this profile tool, and it can be performed. These are the profiles. You can see that these are the all these are the different profiles. Okay, whatever the shape of the profile you want on the surface of the workpiece, that can be performed by using these profile milling operations to create complex shapes or profiles using these profile milling operations, and to produce intricate profiles by using these profile milling operations. Next, coming to the gear cutting. So with the help of the milling cutter we can produce the gears also. Now look at this diagram. Okay, gear cutting. Now this is the gear cutter. Okay, now the gear cutter, you can see that the gear cutter, it's rotating on the periphery, on the periphery of this workpiece. The teeth are cut. Now let us see that these are the teeth are cut on the periphery of the workpiece with the help of this gear cutter. Okay, now we can observe here the different use of the diagram. Okay, so now we can see that this workpiece is rotating in this direction, that clockwise direction, and this axis, the tool axis is perpendicular to the workpiece axis, and the tool direction is by looking from this side. By looking from this side, the tool is rotating in clockwise direction, and from looking this side, the workpiece is also rotating in clockwise direction. These two are perpendicular axis, and this is a rotating cutter, and this is the workpiece. Okay, so once the tooth is completed, then it is indexed. The workpiece is indexed, and it will go to the next tooth position, and the cutter will cut the next tooth. Likewise, all the tooths are cutting takes place by using this gear cutting cutter tool using in the milling machine. You can see both the direction, that is the side view and this front view. You can clearly see that how the gears are formed. Now you can see that this is the how the gears are formed with the help of this gear cutter. So gear cutter is cutting after completion of the one tooth, it will goes to the next portion and it cutting, and likewise till all the tooths are completed. So likewise you can perform the gear cutting operation. Next, slab milling. Now you can see that the slab milling, you can clearly observe this workpiece and the tool, the size of the tool and workpiece you can observe in slab milling. The basic form of the peripheral milling in which the cutter width extends behind the workpiece on both sides. If the workpiece is this side and cutter is more than that, so that entire the surface of the workpiece is cutting by using this cutter. That cutting operation is known as slab milling. Because why the slab is given, the tool is like that flat surface, okay. So that workpieces, those flat surface workpieces behind that size of the workpiece, the tools are used to perform the operation. That operation is known as slab milling. Next, the plane milling operations. Now you can see that the plane or surface or slab milling all are similar to that. So the plane milling mainly the process to get the flat surface on the workpiece in which the cutter axis and workpiece axis are parallel to each other. So in the plane milling, the axis of the cutter and workpiece axis both are parallel, and the flat surfaces are going to perform using the plane milling operation. Next, cutter, you can see the plane or slab milling cutter. It looks like the slab milling or plane cutter used on this flat surface workpiece. You can perform the operations. So it can be used the horizontal milling machine to perform this plane milling operation. Next, pocket milling. Whenever you want to make some pockets, then you can choose this pocket milling. Now you can see that this is the tool and this is the workpiece, and we are performing this rectangular pocket. You perform the rectangular pocket milling. So this tool can have the moving in this direction, okay. So now we can perform the pocket milling. It may be the rectangular, or it may be the circular, or it may be the oval shape. Whatever the shape of your pocket is required, in that shape you are going to perform the milling. So that is known as a pocket mill. Now you can shown here the rectangular and circular pocket milling operations, how we can perform, that is visualized in this slide. Next, helical milling. So whenever on the workpiece you want to make the helical groove or thread type groove you want to make, then you can use this specialized helical cutter to perform the helical milling. Okay, now you can look at this tool holder, and this is the cutter. You can see that this cutter, the cutting on this periphery of the workpiece, on this periphery of the workpiece, these are the helical groove. So this groove is like a helix. If the groove is like a helix, that helical groove will be performed using this specialized tool cutter, and this job is fixed in the vise, and this job is rotate, and the cutter is rotating, and this helical shape of the groove will be cutting on the workpiece. Okay, then for specialized this operation we can perform this setup, and we can operate the milling, that is known as a helical milling operation. This operation is known as helical milling operation. Next, climb milling. So now you can look at this climb milling. This also you can call it as a down milling. Okay, now you can clearly you can observe all the milling operations are broadly classified as the down milling and up milling. Now you can see the climb or down milling. So now what is the direction, you can clearly observe here. This is the workpiece is rotating in clockwise direction, and we are giving the feed in this direction. Okay, now here you can see that the tool will come and contact this point, to come and contact point, and this is the thickness of the material is starting point, it's removed, and it's coming, and slowly it's coming to the zero thickness. So that is a maximum thickness, zero thickness. At the starting, the tool will start the maximum thickness of the material wants to remove. At the end, it's coming to the zero thickness. The gradually reducing this thickness, the material is removed in this direction. The material is removed in this direction. Okay, the tool cutter will move in this downward direction, and the metal is removed. Like this, the workpiece will come and remove the material like this. So that is the operation, you can call it as a climb milling or down milling. Next, the up milling. Okay. So the up milling, the shape of the shape, you can see that here the tool cutter is moving. Okay, now the tool cutter is moving in clockwise direction, and the workpiece is moving towards here. Okay, so that up milling will be taking place. Okay. The straddle milling. Now you can perform the straddle milling. And now you can look like this straddle milling. There is a R bar. In this R bar we are fixing these side and face milling cutters, and here there is a two side and face milling cutters. These two are provided with the spaces to have that gap, and this is the workpiece, and in this workpiece we want to machine both this side face and the bottom face. These two simultaneously you can perform the machining operations, then you can operate this straddle milling. Okay. Likewise, there is a different set of cutters you can fix, and you can perform the straddle milling operation. So, in this the simultaneous these two sides the machining operations can be performed simultaneously by using this straddle milling operation. Next, gang milling. You can see that it looks like a straddle milling, but there is a slight different of the gang milling is this is the R bar. In this R bar you can fix the number of the cutters, the side milling cutter. Now you can see that the side milling cutter, okay, and these are the plain milling cutter, okay. And this is also side milling cutter. Like several milling cutters you can perform, and this is the workpiece. On the workpiece you can perform the side milling, and on the top also you can perform this milling, okay. Simultaneously you can perform the plain milling and side milling, bottom milling. All the operations can be performed by using the set of tools we are mounted on the R bar, and you can perform that type of milling operation is called it as a gang milling. Gang, the mean itself, the number of tool cutters are acting, and you can perform the simultaneous the machining of several faces at a time. Then we are using the gang milling operations. Because if we want to use the only single milling cutter, there is a lot of time is required. Once you complete the one operation, go to the next place, like that it will take more time to complete the operation. Instead of that, we are using the gang milling setup. At a time you can perform all the operations that is possible by using this gang milling operation. Next, saw milling. Now you can see that the sawmill, it's like a sawmill. How the sawmill, the blade will cut, that you are using this R bar. In the R bar you are fixing the sawmilling cutter. The sawmilling cutter, whenever any piece you want to separate, then use this sawmilling and you can perform the sawmilling operation. You can perform the sawmilling operations. I think these are the different types of operations that can be performed on the milling machine. I hope everyone can understand these operations which are performed on the milling machine. Thank you.